In the last video we finished a throwaway widget so that now we can start to implement drag and drop for our item slots. However, before we can start with that, there is some preparation work we will have to do in this video. So let's get started. Go to your widgets and on our inventory slot, go to the slot button and scroll down here under interaction, change the click method to precise click and the touch method to precise tap. Currently it was set up so that when we press down our mouse button and release at any time, our click event would fire and we wouldn't be able to drag our widget. But that way, when we click once, our click method will be fired, and if we hold down and drag, we can implement our drag and drop later. Also go to the graph and override a function called onMouseButton Doubleclick. Because when we double click, we want to quickly use our item, so you don't have to right click anytime and go to use. First we want to check something, so search for branch, and we will check, first off, get the mouse event here and search for is key down, is mouse button down. Mouse button will be our left mouse button. And we also want to check whether our slot button is enabled, so that we cannot double click when our slot is empty, and add another pin and check with our item info, break that and check if we can actually use our item or if it's just a quest item that we need to carry around. Connect the AND to the condition. If it's false, go to the return node, and for the return value search for handle. Then for the true path we will get our inventory reference and call useItem@index with our slot index. Then connect it to the true and go to the return node. Compile, save. That's it for our double click. We can actually test that. So if we pick up our health potions and double click, we can see you used health potion and we only have 49 left. Also, before we can start working on drag and drop, we want to close our inventory slot and go to our BP inventory to add two new functions. The first one will be called add_to_index, and that will be used when we drag a stack onto another stack of the same item to recombine the stack. For the function we also need two inputs, so create one. The first one will be an integer and it will be called the from index, and the next one will be our to index. And same as with the other functions, we need an output that is a boolean called success question mark. Now first we will get our from and to index and promote them to local variables so we can access them later. Call that local from, and the to promote to local variable local to, and connect the execution path here. After that we want to go in a branch and check for some things. So grab in the slots array and get from it at our from index and copy this and get from the to index because we want to compare our classes. So break our inventory slot structure and break it down here, and then we'll check whether our item class from the from index equals the item class from our to index. And another thing we'll have to check is that our amount at the to index is less than our maximum stack size, which means it isn't a full stack, so we can actually add something to that. Also add another pin for the end, and the last one will be get item info at index. Index you can plug in either the local from or local to, because we already checked that they are the same class. And get the item info, break it, and connect the can be stacked to the end. Then connect the end to the condition, move everything over here. If it's false, we will return with false. However, if it isn't, we will get our item class, promote that to a local variable, call that local class, set that here, and after that we will go in another branch, and this time for the condition we will get our maximum stack size minus, then get amount at index, and the index will be our to index. Plug that in for the minus. So that is the amount of items that can still be added to our to index. And we want to check whether that is greater or equal than the amount at our from index. Connect that to the condition. So if it is, we will grab in our slots array and set array element. Index will be our to index. Then split the item struct here. Item class will be our local class. And the amount will be our get amount at index. So the amount at our from index plus the amount of our to index. Copy that get amount function over, plug that in for the plus, connect it to the item amount, and connect the true to the set array element. Move everything over just a bit. And after that, we also have to clear our from index. So grab the slots array again, set array element. Index will be our from index. And split the struct pin, leave the class as null and amount at 0. Then after we did that, we call our update slot at index function. The index, we will first update our from index, copy, paste, and after that update our to index. Then at the end we return, and this time we return successful. Then for the false path, we will grab our slots array, set array element. The index will be our local from. Split the item. So item class will be our local class. And the amount will be our get amount at our from index. So what was there before? Minus, search for minus integer, and we want to subtract our maximum stack size minus the amount at our to index. So we subtract the amount that was added from the amount that was there before and plug that in for the new amount. Then copy over the slots array and set array element. This time we'll set the to index. Split the item, class will be our local class. And we will make it a full stack now, so the item amount will be our maximum stack size. Connect the set array element nodes, and after we set that, we can go into our update slots and return successful. Now that's it for our add to index function. We will also need another one that is called split stack to index. It will basically do the same thing as our split stack function, but this time we will not search for an empty slot, but we will split to the stack that is defined when we call that function. So create a new input. First one will be our from index. which is the index of our stack. Next one will be the to index, which has to be an empty slot. And the next one will be the amount we want to split. Also create an output that will be success, question mark. Its type will be Boolean. Now, same as we did before, promote them to local variables. That is our local from. The to index is our local to. The amount will be our local amount. Then connect them here. After that, we will need a branch. And for the condition, we will check is slot empty. So our to index has to be empty, and our copy that is slot empty. Our from index should not be empty. So of the empty, search for not. Then add another pin, and we will get item info at index. From our from index, we will get the item info, break that, and grab that can be stacked. Then add 2 more pins. We also want to check whether our amount is greater than 1, otherwise we can't split. And the last thing we want to check is that our amount at our slot is greater than the amount we want to split. Connect that to the end, connect the end to the condition. If it's false, go to the return node, return false. If it isn't, we can grab our slots array and get from it at the from index, break that, and promote the item class to a local variable called local class. After that, get the slots array again and set array element. The index will be our from index, and for the item, the class will be our local class. And our new amount is the amount from our break inventory slot here minus the amount we want to split. So minus our local amount, connect that to the item amount. After that, grab the slots array, paste it, and set the next array element. Now we will set the to index, and its item will be our local class, and the amount will be our local amount. After that, we will update our slots. Copy that, so we have it twice. First, we will update our from slot. Doesn't matter really in which order you do that. And after that, our to slot, before we return true. Compile and save. Now that's it for our new functions. There is one thing left to do for our preparation work, and that is the widget we will show when we drag an item. So go to the widgets folder, create a new widget blueprint, call that dragged item. And in here, first change the setting from filled screen to desired on screen, kill the canvas panel, and we will start with a size box. I will choose a width and height override of 64 by 64 pixel. Then add an overlay to the size box. And on top of the overlay, add an image, which will be our icon. Set that to fill and give it a name, icon. And then also add a text to our overlay, and that text will be our amount text. Make sure it's a variable and it's aligned to the right bottom corner. For the font size, use something really small like 10, and you could choose the font type to bold, italic. Also make sure that you give it a little bit of padding, so 1 pixel from the right and 1 from the bottom. Then for the text you could type in something like X99 just to see how it looks. Now get the shadow color and make that fully opaque, and now you can actually see our number. Also lower the shadow offset to something like 0.7, worked just fine for me. In the last setting we have to change the justification, set that to align text right. Now hop over to the graph and create 2 new variables. The first will be our item info for the item we're dragging. Variable type will be s_item info. Make sure that it's editable and exposed on spawn. Then create another variable, and that will be our amount. Its type will be an integer and also editable and exposed on spawn. Now on construct we will get our icon and set brush from texture. The texture we will get from our item info, break that, get the icon, and then we want to check whether our item can be stacked. So if it can be stacked, we will get the amount text, set text, and for the int text we will search for format text. I think we did that in the last video as well. For the format, type in X, then open a curly bracket, type in amount and close the curly bracket. For the amount, you will grab in our amount, convert it to a text, and the result we will plug in for the int text. Move that up, and if our item cannot be stacked, we will simply get our amount text and set the visibility to hidden. Compile and save. Alright, that's everything for our preparation work. In the next video we will start dragging around our items, so see you then.